Hi everyone, welcome to MOSCAN. So in today's video, we are taking one question which is a very simple question. Three NMOS are connected in stack, gate voltage and supply voltage is given to us. One resistor is given to us which is connected with the MOS M3 at source. The current flowing through this resistor is given in terms of this node voltages which is V1, V2, V3. So current which is flowing from this resistor is given as V1 minus V3 milliamps, and also the value of this resistance is given to us which is 0.25 kilo ohms. And in this question it is asked to calculate the reason of operation of all these three MOSFETs. Also it is given to us in this question, let's consider all these three NMOSs as identical and threshold voltage of each MOS is given to us which is equal to 1 volt. So let's start analyzing this question. So whenever these kind of questions are given where region of operation is asked to you, since we don't know the mid voltages, like if we know this node voltages, it's become a very easy question. We only need to find out VDS, VGS, VT is given and we can tell in which region of operation MOSFET is operating in. But since these voltages are not given to us, so whenever we need to attempt this kind of question, we need to make an assumption first. And through numerical solution, we need to see whether our assumption holds true or not. So that's what we will do in this question also. But before that, let's start from bottom part because here every information is given to us for this resistance, current and resistance value is given to us. So if I have to write the voltage equation for this resistor, I can simply write V3 is equal to IR. I is given to us V1 minus V3 milliamps. So I can make it as 10 to the power minus 3 amps. And the resistance is given to us 0.25 kilo ohms. So I can write this at 0.25 into 10 to the power 3. So this 10 to the power 3, 10 to the power 3 will get cancelled out. And I will get V3 is equal to 0.25 V1 minus 0.25 V3. Right. If I solve it further, I will get 0.25 V1 minus 1.25 V3 is equal to 0, right? And if I make 0.25 as common, so I will get V1 minus 5 V3 equal to 0. So this can be my equation number 1, right? Now let's assume M1, M2, M3 are operating in saturation region. We are assuming this. Okay. Now let's see whether our assumption holds true or not. So if I'm assuming all the three MOSFETs are operating in saturation region, so for saturation the condition is VDS should be greater than or equal to VGS minus VT for each MOS, right? This is the one equation. So let's start analyzing from top MOS, MOS M1. If we analyze for MOS M1, source potential we don't know, which is V1 we have given in the question. Gate we know 5 volt and drain we know 6 volt. So if I write this equation for MOS M1, VD will become 6 volt. VS is given to us V1. This should be ideally greater than or equal to VG, which is 5 volt. VS is again V1 and VT is given to us 1 volt. So V1 will cancel out. 6 should be greater than or equal to 4, right? And that is true. 6 is greater than 4. So that means M1 is operating in saturation region, and that we can tell without having the knowledge of V1 because V1 will get cancelled out in terms of source voltage for VDS and VGS calculation. Now let's talk about M2 and M3 MOS. But we can't directly apply this equation for MOS M2 and M3 because if you see there are two unknown variables. For M2, drain source both are unknown. Similarly for M3 also V2, V3 and drain source both are unknown. So first of all we need to find out at least these node voltages V1, V2, V3, then only we can tell whether MOSFETs will operate in saturation or not. So since we have assumed these all three MOSFETs are operating in saturation, so that means whatever current will flow from MOS M1, similar will flow from M2, similar will flow from M3 and the same current will flow from this resistor also. So ID current would be same across this MOSFET because all are in series. So we know in saturation, if MOS M1 and M2 are having the same current, so saturation current, which is equal to half mu n C ox W by L of MOS M1 into VGS of M1 minus VT whole square should be equal to half of mu n C ox W by L of MOS M2 VGS 2 minus Vt whole square. So ultimately all MOSes are identical, so these parameters will get cancelled out. Even W by L will get cancelled out because MOSes are identical. So we will be left with VGS1 minus Vt should be equal to VGS2 minus Vt, right? So even Vt we can cancel out. So VGS1 and VGS2 should be equal, right? This is the key equation which will be applied for all the three MOSes, and then we will get the equations. So let's apply this equation for MOS M1 and M2. VGS should be equal for both these MOSes. So I can write it as VG if I have to write for MOS M1. So 5 minus Vs is V1. Let's take Vt also. Vt is 1 volt. Should be equal to VGS minus Vt of MOS M2, which is 4 minus V2 minus 1. So that means 4 minus V1 should be equal to 3 minus V2, and V1 minus V2, if I bring this term here, should be equal to 1. So this will be my equation number 2, right? Now the same equation I can apply for MOS M2 and MOS M3 also. So VGS for MOS M2 and VGS of MOS M3 should be same. So if I write for MOS M2, VG is 4 volts, so VG minus Vs is M2 minus Vt should be equal to VG for MOS M3 is 3.5 volt, VG minus Vs is V3 minus Vt, right? Now I will get 3 minus V2 should be equal to 2.5 minus V3. So I can write it as V2 minus V3. I have brought this term on the right hand side. So V2 minus V3 should be equal to 0.5. This is my equation number 3, right? Now you know I have equation number 1, equation number 2 and equation number 3. Equation 1 is between V1 and V3. Equation 2 is V1, V2 and equation 3 is V2, V3. If I add equation 2 and equation 3, so I will get equation between V1 and V3, and then I can get one unknown variable value, and then I can get all the variables. So let's add equation 2 and 3 here. If I add equation to equation 3, so V2 will get cancelled out. Ultimately I will get V1 minus V3 is equal to 1.5 volt, right? This is my equation number 4. Now I can subtract equation 1 minus equation 4. So what I will get? Let's solve it here. Equation 1 is having V1 minus 5V3 equal to 0. And I'm subtracting equation form out of that. So V1 minus V3 equal to 1.5. This I'm subtracting. So V1 will get cancelled out. We will get minus 4V3 is equal to minus 1.5. That means V3 is equal to 0.375. This is what we will get, right? Now this is what we have calculated. V3 is equal to 375 millivolts or 0.375 volt. So I can get V1 also from equation 1. So if I keep V3 value in equation 4, so I can get V1 equal to 1.5 plus V3, and V3 have calculated 0.375. So V1 will be 1.875 volt. This is V1. Now V1 also we have gotten, so we can get V2 from equation number 2. So you have to calculate V2 from equation 2. V2 would be equal to V1 plus 1. V1 we have calculated 1.875. If I add 1 here, so V2 will get 2.875 volt. So now we have gotten all the values V1, V2, V3. So we can simply get to know the region of operation for all these three. Now since we know the value of all the three node voltages V1, V2 and V3, So we can calculate the region of operation for MOS M2 and M3. For MOS M1 we already have calculated, it is operating in saturation region of operation. So we need to apply this equation for MOS M2 now. So for VDS we have to calculate MOS M2. So VD we know is V1. V1 we have calculated as 1.875. V2 is source for this MOS, which is equal to 0.875. This should be greater than or equal to VGS. VG is 4 volt. Source voltage is V2, which is equal to 0.875 minus VT, which is 1 volt. So this is 1 volt, which should be greater than or equal to 4 minus 1, 3 minus 0.875 should be close to 2.125. And that's not true, right? 1 is not greater than 2.125. That means the assumption which we took for M2 that it is operating in saturation is not correct. It will operate in linear mode of operation, but before that we also need to check its VGS should be greater than VT. So if I calculate VGS for MOS M2, 4 minus V2, V2 is 0.875, that is very high. 3.125 something will get, which is higher than VT of this MOS. So that means MOS is on, but it will operate in linear mode of operation. So this we calculated for MOS M2. Now let's calculate the similarly for MOS M3 also. VDS if you have to calculate, so that will be equal to V2 minus V3. V2 we know is 0.875. That should be, and we have to take the difference with V3, which is source. V3 we have calculated as 0.375. This should be greater than or equal to VGS. VG is 3.5 minus VS is 0.375 minus 1, which is VT. So this is coming as 0.5, should be greater than or equal to 2.5 minus 375. That will be something around 2.125. So again, this is not true. 0.5 is not greater than 2.125. So this will operate in linear. M3 will operate in linear. Again, we need to check its VGS should be greater than VT. So VGS is equal to 3.5 minus V3. V3 is 0.375. So that means it is coming close to 3.125, which is higher than the threshold voltage of this MOS, which is 1 volt. So M3 is also on, but it will operate in linear mode of operation. So the assumption which we took for all these three MOSes to operate in saturation, that holds only true for MOS M1. M2 will operate in linear, and similarly M3 will also operate in linear mode of operation. So this is the answer of this question which was asked in this question to find out the region of operation of this MOSFET. So thank you so much for watching this video. If you have watched this video till here, please share this video with your friends. If you haven't subscribed to our channel, please do subscribe. Thank you.